Okay, so Luis is gone, so I guess I'm starting. All right, so we'll do a sound check first. Do we have sound? All right. Sound check. Hi, I'm Phil. I used to work at a video game company called Trans Gaming, so I ported a lot of video games to the Mac and Linux. I also used to work on Corel Painter for 8 years, which is a drawing program. So the iPad Pro, me from 6 years ago, super excited. I'm now the lead developer of a point-of-sale software called Lightspeed Onsite, which you will actually see in my demo. But I'm also a community organizer. I believe in building communities and making them as easy for people to get into as possible. So I founded the local Ottawa Cocoa Heads chapter. I'm from Canada, by the way. And I wasn't expecting to speak today, so that's why I'm wearing shorts. I do have pants. And as the t-shirt attests, I'm also the organizer for the sister conference of NSSpain called NS North, which is in Canada and has been going for 3 years now, so very much a sister conference. And we are Canada in Ottawa, we're 45 degrees north latitude. This is 42, so it is technically north of here, so I'm still good. So enough about me. Talk a little bit about the issue that I wanted to discuss today that was happening and that brought this whole talk together. So Lightspeed is a point-of-sale system. Think you as a shop owner, you're selling clothing or bike parts or something like that, and you want to be able to use a Mac to control all your inventory, to know how many dresses, shirts, shoes of a certain size and color you have and where they are in the store, and you want to be able to maintain inventory. You want to be able to scan things with a handheld USB scanner, have a cash register, have a receipt printer. All of the Lightspeed is all of that. It's pretty awesome. But there was a problem with the version of last year. People were typing in the program, entering customer data, like customer comes in the store, you want to make a new gift card or something, so you need to enter customer information. Every time they buy something, you don't always scan. Actually, even when you scan, these USB scanners, they basically behave like keyboards. So when you scan, it's basically typing really fast for you. So it's all coming in over as keyboard stuff. And what was happening was very strange to us, was after as early as an hour and as late as 6 to even 24 hours of just using the app, you couldn't type anymore. I mean, everything would work. You could click buttons and everything. It wasn't frozen. Just couldn't type. So that was kind of a pain in the ass. And of course, RQA never caught it because RQA doesn't use the app continuously without restarting it for hours at a time. We had one of our developers, one of my colleagues, was able to, after a whole day of 6 hours of using the app and typing, he got the app into that state. So we're like, yes, we got one. So we tried to attach the debugger, and nothing was really found. And we tried to do some spin dumps so we can figure out where the app is not recording things. We look at console, nothing. So we said to ourselves, we need to add more logging. Everywhere we have keyboard input, we'll want to log, I press this key and stuff like that. And in the app, it's fairly centralized, so it should be fairly easy. So, let's get an instrument to build going, and let's reproduce a problem. All right, took one guy 6 hours, and that's really not super efficient. So this was dubbed keyboard gate, which is a term I hate. But I'm exercising my hate for it by putting on this slide. So basically, our customers were seeing it. We had a really hard time seeing it. And this brought back what was retconned as mousegate. So the versions from last year of Lightspeed, if you had a magic mouse, which is a really nice mouse, it would crash. So you would scroll, and eventually the app would just crash. We're like, oh. So when we got the support call, we would just send them a mice with a wire, and at our expense, saying, sorry, use this mouse. And people were happy, but obviously it was A, a support call, B, an apology, and C, sending a mouse at our expense. Not really a good... So I'm telling you this because I'm putting it into context, because we're looking at these keyboard issues, you're thinking to yourself, I could use Automator and all these scripting things that I know about, like UI scripting, to be able to click on things and fake typing and all of that. But I had a hunch that if I do that, I would have the magic mouse issue would not show up because I'm faking the mouse, right? So it works with wired mouse. So if I use a scripting solution like this, well, maybe it's fraught with peril. Maybe it's not going to reproduce the problem ever, or even in a way that's consistent with what the user is doing. You really have to mimic as much as possible what the user is doing. What is the user doing? Typing on the keyboard. So as much as I don't like typing on the keyboard, because programming is just efficient laziness, and look at Swift, how less keywords we have and less typing we have to do. That's great for my wrists. But really, you have to think outside the box, and you have to think about what would you do to make yourself able to reproduce this problem without using a lot of typing. Because even if that person is, well, if a person is a developer, that's usually very expensive in the developer's time to be able to produce this. But if you take junior salesperson that just came in to work on this, hugely inefficient even for that person to be able to try to reproduce this problem. You could do a site visit to go see customers that have this problem, but that's pretty expensive to send people to a site visit, especially if the customer that's having it is like in New York and you're in Ottawa, and then you have to pay a whole lot of travel. Nobody really wants that. So, Arduino to the rescue. How many of you know about Arduino? Right, about 3/4 of the room. Awesome. For those who don't know, Arduino is a really small microcomputer. It's really easy to program, as I will show you in a moment. It's open source. It's specs and software, so you can download the software for free and run it on their board. And since the specs are open source, you can, if you like one board and you want to make 1,000 copies of it and not buy 1,000 copies from Arduino, which you should do, you can make copies. The specs are open source and make your own clones. It's really useful. I've started using also in wearable computers something called the LilyPad. So it's basically a really small Arduino boards that you can sew into clothing, and then you can have LEDs, buttons, batteries, sounds, actuators, lots of things. It's really cool. And even better, it's got multiple interfaces, Bluetooth if you want to make something wireless, like let's say you wanted to press a button here, or an actuator that's movement-based, so you can be like Iron Man. But it's got serial and it's got USB. So the board that I'm going to be talking about today is called the Leonardo. I do have one here, and if we have a camera, we'll be able to start showing you what's happening with this board. So I asked Luis at a really short notice if he could, because I was planning for this tomorrow, if we could have a video feed of the Arduino board as I'm playing with it so you could see it, because obviously right now you're not seeing anything. Well, you can see me, so you can see the board. So I'm going to go like this. There we go. All right. So got my board. Awesome. I think I'll take it from here then. All right. So the board by itself does nothing. It's got you can battery power it. You can see there's a little power thing here. No, you can't see it here. There we go. So you could plug in power here. But since I'm going to be making this a USB keyboard and mouse, because this has the USB and keyboard, the USB mouse and keyboard controllers on it, it can behave like a keyboard or mouse. So what I'm going to do is I'm going to plug it in using USB and using it as a source of power. So let's do that right now. And thank you, I said no warnings. So now it's booting. Can you see the blinking lights at the bottom? I can. All right, can we see the blinking lights? It's kind of... All right, so the first program I'm going to show you is if I switch to my Arduino, and of course I can't see this is the second program, there we go. So the first program that we have, and you guys can see that. This is just a very simple Arduino program. So what it does is it will blink. Like there's a power LED and there's just an LED you can control next to it. So I can make this LED blink, and it's pin number 13. So all of this is documented in the Arduino documentation. So yes, 13 is a magic number, but everything in Arduino is magic numbers. It's a language you can define. It's a language you can define with lots of macros, and in fact, there's lots of macros already predefined. I just went for the shortcut here and used 13. So what we're going to do is we're going to write to pin 13, and then for a high to put voltage up, and then turn it off. So this will make it blink. So if I hit this button here, it will actually compile the program, download it to the Arduino, and hopefully if I can, of course this demo worked. There we go. Live demos. Great. No. It's a good thing I tried this before. Hope the rest of my demo isn't screwed, but basically, blinking light. Yeah. Yes. All right, now for my second trick. All right, so now what I've showed you is I can make a tiny program, and I can download it to this Arduino board via USB, and then it will just make a light blink, which is not super exciting, but hopefully the rest will be. So I'll let it blink. I mean, if I unplug it and I put some power on it, it will just reboot and run the same program and just blink. You know, so it's not super exciting, but it is a program. So let's switch back to show you light speed. All right, so this is Lightspeed. So this is my personal store. It's the Acme store. So you can buy a lot of things for Acme. If you're, I have one customer. He's called Wile E. Coyote. And actually, you can see him in my list of customers here. So actually, there we go, Wile E. Coyote. So I've got a bunch of products. Birdseed, of course. Smokescreen bomb. Dehydrated boulders. Really useful. But what I want to do, and you can see my tests here, what I want to do is I want to just create new products all the time, right? I want to create products, and what users were telling us is when they type in, so creating a product is an operation where you would type in, and then save it, and then come back, and then what they would said is if they tab out to another application and tab back in, command tab back in, it increases the odds of this happening. So let's do all of that just in the app itself. So we go File, New Product, and you can see that it's Command-Shift-P, right? So new product. I'm going to give it a code. I don't know, code 0004, whatever. And then my description. And then I'm going to save this product. I can press the save button, but you know, controlling the mouse, especially when you're doing it blind like this, it's kind of fraught with peril. And this is what this is a keyboard thing anyway. So I'm going to do everything through the keyboard. I'm just going to show you so there's the save here, so that's Command S, obviously. So save the product, and then close the window, obviously Command W, and then Command Tab out, and Command Tab in, right? So that's the sequence of things that I want to do, and I want to do this repeatedly, so that eventually the app will lock up and stop typing. So perfect job for this Arduino board. So let's go back to Arduino. And now that it's blinking, it's great, like the blinking. And then Control Scroll so we can zoom this. All right. So this is my Arduino program. Now, you can see it's very C-like. It's not exactly C, but it's very C-like. It's got a stack, so we can declare stuff on the stack. Like I have a variable here. And it's got the two functions, setup and loop. And as you saw from the other ones, the blinking demo, I had a setup and the loop, it's the same thing. So setup is you do it once, and loop is you do it continuously. This is not a super fast CPU, so it's like, I think it's 8 megahertz. So it's not going to loop very, very fast, especially when you add delays. But it should be enough for what we're trying to do today. Especially since we're typing, and typing should be fairly slow compared to what a microprocessor can do. So I want you to ignore the stuff that says digital write 2 and whatever has the number 2 in it, because that's not the focus for now. what I have in my setup is I have one thing. I have keyboard begin, right? So this basically initializes the keyboard and USB interface on this board. So it tells it, hey, we're about to do some keyboardy things. There's also a mouse begin if you're going to do some mouse things. But I'm only concerned about keyboard. I'm declaring a variable on the stack, and now I'm going to be smart because I did this before, so I'm going to call it 5100 because if I create a product with the same ID all the time, it will complain. So I'm just going to bump up this number here. And then I have a loop. Control key equals key left GUI. Now, key left GUI is a macro inside of the Arduino language that says basically left command key. It's called control key here because I was formerly a Windows programmer. So let's forget about the if and look at the program itself. So create a new product. Let's delay a little bit, and then we'll press 3 keys. We'll press the command key, the left shift, and the P. So we're pressing command shift P, which is the keyboard for a new product. We delay a little bit to let make sure the signal has been sent, and then we'll release all the keys. And then that creates a new product. Then we'll type in some stuff, because new product by default is in the code, as you saw, the code section. So we'll type code dash. And this is a shortcut rather than doing press the C key, release, press the O key, release. It's a predefined library inside of the Arduino language to do this. And we'll just print the code itself. So it'll be code dash 510001. And then there's no need to release because that's part of the shortcut. We'll tab to the command description, to the product description, and then we'll press save, and we'll close the document with W. We'll increase our counter, so again, very C-like. And then we'll command tab out and command tab in. So here's my sequence of what I want to do with this little board. And I want to let it do that continuously until the program is frozen. And I'll know the program is frozen because if I come in the morning and I look at the app and it's not typing anything, and the Arduino is still going, it's frozen. I don't need to do any kind of image recognition or anything like that, because this is just basically I can be the image recognition. That's why I was able to get away with this base automation, if you wish. There's no need to image capture. Somebody smarter would probably trigger an image capture every time and then save that to a folder so you can look at the state of the application. I didn't go that far. But what we have here is a series of commands that's sending to the keyboard. Now, let's go back to the digital write and digital read 2. If I send this to the Arduino board, like right now, as you saw with the blinking, it started immediately. So if I send it to the Arduino and I say, hey, do this in the loop, I'm in the Arduino IDE. Not super efficient to go Command Shift P into our Arduino IDE and then type in some stuff and then try to save it and then try to close it. And it's like all weird things are going to happen. You're not in light speed. So I added this little hack. All the pins on the Arduino, they're all numbered. So, well, you saw the picture. I'll show you in a... well, I guess I can show you now, actually, because I've got FaceTime. So, can you guys see this? There's a bunch of numbers, and there's analog and digital, right, on each side. This is for analog inputs and digital inputs. I'm using the digital because it's 0 or 1, and it'll become very obvious why. But you can also have analog inputs, like let's say you want to water your plants and you want to test the water. You have a water sensor that gives you a value that's just an analog value. Well, you would use the analog inputs on the Arduino. I'm going to use the digital one, and you'll see why in a moment. So, if I were to run this program without this safeguard here, it would run immediately. So what this safeguard does is it says, hey, we're going to wait to have a signal on pin number 2. So we're going to wait until you close the loop on pin number 2 and it's active. So the way to do that is to connect the ground. So there's a GND in all of this list. There was a ground GND, and there was a pin number 2. So GND is labeled. It's from the bottom here. Where's my ground? It's upside down. Digital. There we go. All right, it's the 4th one on this side. It says GND. So I have a paperclip. You can get an expensive wire or whatever. They come with wiring kits, but I have a paperclip. Fits in the hole. So I plug it into the GND. And So this is what it looks like on the camera. So hopefully we'll see it. So paperclip, plugged in GND, right? There we go. All right, and you can see pin number 2. Well, it's upside down, so let's go like this. It's a little bit easier. See my ground pin? It's got a paperclip, and see my 2 pin, and of course my paperclip is bent at the right angle, so it's going to go in. So I know where number 2 is. But basically, the idea is that as soon as I do this, first of all, it will exit setup, right? Because my setup will not finish until there's a current on the pin. And second of all, it will only do whatever is in the loop if you've got if you close the loop on digital pin number 2. So that way I can control whenever the sequence starts, and if I want to end it, well, of course I could unplug it, or I could just remove the paperclip. So you guys want to see it run?
Yeah.
All right. Here goes nothing. So we got products here, and I can show you the camera at the same time, but I'm going to plug in digital pin number 2. It's the third one from the bottom. And of course, I forgot to load the program. So let's do that. Let's load the program. Yeah. Go ahead and load. Because it's still blinking. All right, did it do anything? Hope so. We'll see. All right. Tab out. Tab in. Next product. All right. So here I have a hardware interface that emulates a keyboard, types in some stuff, and does all the things that our users said that would cause problem, and I can only run as long as I want. And actually, we've tested Lightspeed for 3 days creating products like this, and the database didn't even flinch. It was like, yeah, sure, I think we went up to 100,000 products doing this, so which some people have in their store. So we were not surprised it would get there, but just to get there in sequence was kind of fun. And we saved that database because we needed a huge database of products, and it's a lot easier than to create by hand. So this is really all it does. It runs like this. Now, the sad part about the story is, and I'll have to stop it so I can return to my thing. The sadder part about the story is, even though I got this going and I was able to save the risks of all our developers and support people typing in stuff, I never got the application into a state where it, where it reproduced the problem. So this is good and all, and it's all a lot of fun, but it's not like, What turned out to be the real problem is the application was linking against the Carbon framework. So for those of you old hands know about Carbon? I know, Michelle, you do. All right. So Carbon is the old framework from back in macOS 9. And the application being old, it's about 10 years old, was linking against that version of the framework. And it turns out it's got a bunch of issues for input that we filed radars for that got said close won't fix. So the solution was to migrate the whole underlying part of the application away from Carbon into Cocoa. As you can probably guess, this was not easy. This took a long time, but in the end, we got a better product that didn't have any keyboard issues, and it fixed the Magic Mouse issues, and it fixed a whole bunch of other issues. So it was the right thing to do. And this is kind of what the lawyers would call due diligence. We're trying our best to reproduce the problem that the users had. And even though that particular solution didn't work, it was a lot of fun to build. So I'm going to remove the pin. And you can see that even if I remove the pin, it's still going, because remember, it's in a loop, and the if statement is only at the beginning. So now it's going to the tab out, tab in, and now it's stopping. So we don't need this. We can go back here, and we can hit play. All right, so I had a slide that said demo. All right, so this is my story. What I want you to think is, sometimes it's not just about software. You have to think a little bit about the hardware. Don't be scared of the hardware. I know the hardware is the thing you carry around in your pocket, on your iPhone, on your iPad, your laptop. It's kind of abstract from a software developer perspective. And you know, oh, pin number 2 or pin number 13 or something, that's all weird. It's actually very simple if you get down to it. It's very interesting, and it gets your nose out of your software for a little bit, and eventually you actually write software for it. So something we're good at, right? Writing software. And these little boards are around, and they can do amazing things. You can do robotics also that have actuators and move things around. So interacting software in the physical world, really cool. In this case, my journey was a lot more fun than the solution. And you should totally get at least one Arduino board. They're like $20, so not really expensive. And they're made in Italy, which is kind of nice. So, thank you. Oh, great, didn't play. I want play. What am I saying? This is what happens when you have... Apparently I should have something come out of the laptop, but it's not coming. Whatever. I had the Portal song. I will gladly take any questions, and when we, if you want to ask or talk about Arduino some more, and you want to see it for up close, I'll be available. I'll be here all week. So, any questions so far?
How did you catch the actual bug? How did you know that it was carbon?
Because we, when we filed the bug at Apple, they said, yeah, carbon bug, close won't fix. And then when we switched to Cocoa, the bug went away. So those were, I mean, it's like this proof circumstantial evidence, right, is what it's called. So we don't know for sure that it's carbon, but given that everybody was getting away from it and Apple wouldn't close it, even though they knew about it, was like, yeah. So.
Great, thanks.
Oh. There we go.
Hi, great talk. Did you have any previous background of Arduino?
Zero. I only knew about Arduino by name, and I said to myself, maybe Arduino can help. And then I looked at all the things, and one of them that came out at about the time, Leonardo came out about the time that I was looking for that bug, had the keyboard and mouse controller. It was relatively new. Most cheaper Arduino boards don't have that, and this one does. So it's like $25. Ooh, $5 extra. So I knew nothing about Arduino. I still don't know anything about Arduino, so probably some of you know a lot more. I just know that I can get it into wearables, and my daughters are all into costumes that have lights and stuff, so Arduino.
So how much time about learning the language and, you know?
Oh, it's not very long. If you've programmed anything, it's very simple to program this. Language is like C-based, so most languages are C-based. If you did any scripting, it's very similar. Basically, it's awesome that I got paid to do this. So, but it didn't take very long. It took mostly 2-3 hours from getting the board in the mail to getting this up and going. And then, of course, it ran overnight and overnight and overnight and stuff like that. It was pretty amazing.
Thank you. Thank you.
Still alive. One question back there.
Hi, Phil. You said that it's a C-based language. Do you mean the syntax, or because you also mentioned a stack? Is it a stack-based language like Forth or something like that?
It's stack-based in the sense that you can't malloc. And maybe in the later versions you can, but I'm using an older version because I wanted my demo to work. So at some point you can do some dynamic allocations. So even in C you can do dynamic allocations, but it's C-based in the sense that the syntax is very C-like. You do the ++ operator, it's got it's got the braces, it's got function calls that are very similar to C. You can do function pointers, but you know, it's not C++ by any stretch of the imagination. It's very much its own thing. If you know any basic scripting language, you'd be very at home.
Okay, thank you.
I guess that's it. Thank you very much.